Ja, jag håller på att bygga en soldusch. Jag har börjat med ett element här som utgångspunkt. Och jag har haft det stående i solen och testat att få ut något vatten här i ändarna. Det har inte funkat alls något bra, det blir ingen värme alls. Så nu tänker jag göra en liten åtgärd här och spraya den här svart. Och sätta den i en låda som jag ska isolera med plast på framsidan. Det kommer att säkert ge en bättre effekt, så att följ det här projektet. Jag skaffar någon svart metallfärg här. Hoppas den räcker. Ja, så här ser baksidan ut. Den har jag inte brytt mig om riktigt att göra fin. Och här är fästpunkten jag tänkte använda. Det finns en i varje ända här. Så jag har böjt till några bandjärn här och sågat av. Och ska fästa upp dem här så jag får en bra fästpunkt. Så det blir bra det där. Okay, so now I arranged the box in a good angle here for the sun. I shift to English to make this available for a broader audience. This super interesting project, the solar shower. So now I have mounted the radiator inside the box, and also the heater, which will not be electrically connected anymore. It will be the vessel, the insulated vessel where the warm water is stored. And the height difference between the radiator and the vessel is important, because warm water will raise and go up and cold water will go down. There will be a self-circulation in this system that is propelled by the sun. So the radiator will automatically give away warm water at the top that will circulate up to the insulated vessel, and then we will have a circulation down of cold water. So this will go by itself and fill up the vessel with warm water. It's only 10 liters, so it's not so much. It could have been a bigger vessel. And here is some components I've purchased for this project. Quite inexpensive things actually. This is 100 crowns, about 10 euro, 10 US dollar. Okay, now I have connected everything. Not very beautiful, just for a first trial. I will not try to explain in detail how this is connected. I will do it in a schematic later instead. But they are connected here to this heater that can be powered by electric power, of course, and I have that available. So this entire project is more like a play than rational. Okay, but well, if there's a power failure and you want to take a warm shower, then this will be very good. So now the system is filled with water and hopefully de-aired. It's important that there are no air bubbles that will collect on high points that will stop the self-circulation. I put the plastic film here to obtain a more greenhouse effect inside the box. That's important. I will replace it with a polycarbonate layer later if this will work. So small steps. And I have also assembled a little temperature sensor inside here. I don't know if you can see it. A small wire that goes inside, and we will be able to read out the temperature, and it's steady rising inside. It was below 20 when I started, so there is something going on inside the box. And hopefully we will have this self-circulation here up to the insulated heater. Okay, so now there's sun, and the day after the erection of this construction, and of course sun is needed for evaluating its function. And now I can actually feel that the tubing coming from the top of the radiator is apparently hot, warm, while the supply that goes to the bottom part of the radiator is cold. So now there is some kind of circulation, and the nice thing is that the warm water goes up into this insulated vessel, and if the sun goes away in nighttime, this vessel will hold the temperature for hours. So it will actually be, some heat will be remaining the day after. So that's the nice thing. This can work when there is sun, and it can collect the collected energy in the insulated vessel. Very nice. The temperature inside this compartment is now 38 degrees, which is top level so far. So this is really nice. I will make a schematic later that you can really see how this is connected. So that will be more clear in a schematic picture. Thank you so far. I forgot to show you the ultimate test. It's actually to feel the water, and it's really nice. And I can add one technical detail. The area of this sun radiator is about slightly less than 1 square meter, and that will mean it will gather about 1000 watts ideally from the sun. 1000 watts, that's what radiates to Earth from the sun. And this electrical heater is at 1500 watts. So actually the power levels of these two ways to heat water is similar. This is beautiful. So easy. So independent. Time for the final test. The sun has gone almost down. It's no power anymore in the sun, and it's time for a shower. I've been working all day. It's 8:30 in the evening. So now we'll see if the energy is stored well in this vessel. So I start the shower. From the beginning it's cold because the tubing is now the heat comes. Beautiful. It's perfect. Perfect temperature. Oh, it gets even warmer now. The vessel only contains 10 liters, so I have to save it. Some comments on safety. You may react on this very simple setup to have this outside, but it's connected to a earth leakage circuit breaker, so that's a good thing. That would stop power if there is a problem with that. And I also have a simple cover here to protect it from rain when we are here. Okay, this is a schematic of the system. Assume that the system is filled with cold water. We have the radiator here, we have the water heater here, which is in this case an insulated vessel only. Then assume that sun is shining on the radiator and heating the water here. The water will then get hot and its density will get lowered, so it will be lighter than cold water. That means it will try to go up this way and flow into the insulated vessel. And when it do so, there must be water getting out of the vessel too, and that will happen from this bottom position where water will go down to the radiator. So you will get the spontaneous flow around like this when the sun is shining on the radiator. So it's important that this insulated vessel is above the radiator. That's very important, else there will be no self-circulation. Then what will happen when we open the valve to get out water? Then of course it must be refilled in some way, and we have the cold supply that is positioned here. So we take out warm water here, and then we want the water to go this way when we take water out here. We don't want it to go that way by the radiator. We want to get access to the hot water in the vessel. And that is how it worked for me. If it would be more favorable for the flow to go this way, it needs to be some kind of flow restriction introduced here, so that the preferred path is through the insulated vessel. So that is the concept. Very welcome to comment. Thank you.